So we have one more differentiation technique that we need to talk about. And the goal is to be able to handle situations like this thing, right? It's not a function. The graph is a circle, it's not a function. But I'd still like to be able to talk about its rate of change, because it has a rate of change. I mean, if you pick a point, it's changing up or down, right? We should be able to talk about this. All right, so to do this, I want to take a step back and look at this. Obviously, this one we could do. It's just a power rule. But I want to really stop and think about what we're doing when we differentiate this thing. Right? What I'm doing to find the derivative is I am really kind of going old school algebra and just taking the derivative of both sides. Right? So on the left side, I have dy dx. And on the right side, I have d dx x squared plus 1. Now, dy dx we just leave alone. That's what I'm trying to find, the rate of change of y with respect to x. So dy dx equals, and over here I'll just use my power rule. Derivative of x squared is 2x, derivative of 1 is 0, and there's my answer. Or yeah, sometimes we'll write this y prime equals 2x. Okay, this is the logic that I'm going to use when I'm trying to do derivatives of things that I can't necessarily solve for y. So take a look at this thing. All right, here's what we're going to do. Let's do what I said. Take the derivative of both sides. The derivative with respect to x of y squared equals the derivative with respect to x of x squared plus 1. Now, the right side is still 2x. 2x plus 0, right, which is 2x. Nothing unusual happening over there. On the left side, what I need you to see is that this is a chain rule situation. Right? This is a chain rule situation. Remember, y is a function. Y is a function of x. So what I have here is thinking in terms of the language we use for the chain rule, y is my inside function, and this squared is my outside function. All right, so let's see if I can't actually write this in chain rule terms. I'm going to let g of x equal x squared and h of x equal y. All right, so then g prime of x is 2x, and h prime of x is y prime. All right, so then look at what I have here. What am I asking for? This is the derivative with respect to x of y squared, which is g of h of x still equals 2x. Don't lose track of that right-hand side. I know we're not changing it anymore, right? But you still want to, don't forget it's there. Keep writing it. All right, so my chain rule formula says this is g prime of h of x times h prime of x equals 2x. So let's see, this is g prime of h of x, that's y, times h prime of x, which is y prime, equals 2x. Now, g prime of y, right? G prime is here. And if I put y into that, this is 2y times y prime equals 2x. And if you look back right now look back at the derivative of y squared. You see how this really was a model chain rule situation. I took the derivative using the power rule, right? Y squared became 2y. Then I multiplied by the derivative of the inside part. Derivative of y is y prime. Now, we're not quite done. When we're doing these, the last step you want to do, remember, the question is always, what is y prime? What is dy dx? So I want to solve for that. So all I'm going to do is I'm going to divide both sides by 2y, and I get y prime equals x over y. And that's where I would stop, right? You don't want to try to substitute in there for y. If I could solve for y in terms of x, I wouldn't have had to go through all of this. right? So that's the end. That's our derivative, and the name for this, right? This process has a name. It's called implicit differentiation. So let's look at another one, right? Let's see how this works. So you can go ahead and try this one if you like, right? See if you can work this out. Then start it up and we'll do it together. Okay, very familiar process. Derivative of both sides equals the derivative with respect to x of the cosine of x. All right, we know how to do the derivative of a sum. This is just the sum of the individual derivatives. And the right side derivative of cosine of x is minus sine of x. All right, well, on the last example, we saw how to do the derivative of y squared. This is 2y prime plus y prime equals minus sine of x. All right, now I still got to solve this for y prime. So look, let's factor it out. Y prime 2y plus 1 equals minus sine of x, and then divide. Y prime equals minus sine of x over 2y plus 1. And that's it. There's my derivative, right? There's dy dx. Okay, so what's next? We're not quite done. There's a couple of other things that can happen with this. There's some interesting implications when maybe the denominator becomes 0 and what's happening then. So I do want to do a few more examples, right? And that's what we're going to do in the next lecture.